Hey everyone, welcome to another episode of Visual Studio Toolbox Extending VS Edition. I'm your host, Leslie Richardson, and if you're watching this, hopefully you're watching it because you have seen every other part of this ongoing playlist about how to extend Visual Studio, specifically using the new VisualStudio.Extensibility model. So joining me today is Matteo Prosperi from the VS Extensibility team. How are you doing?
Doing great. Hi, Leslie.
Great. So a couple of housekeeping things. Once again, this is part of a wider playlist. We've been at it for about a year now. So if you are new to this, do not watch this video. We are about to get into some complicated stuff. Please start at part one of the link to the playlist is below. And if you're not down to start all the way at the beginning, at the very least, go watch the episode that happened right before this one because we're basically continuing the conversation that we started there about not just what to do when you need to create an in-proc extension, but in this episode, we're going to be talking about what happens when you need an extension that consists of both in-proc and out-of-proc components. So, Matteo, why would people need to do this?
I know some people just want the pain, I guess.
Yeah, I mean, some people are into that.
Yeah, no, this is actually came up a lot in feedback that we have internally from other teams and for people who write us messages on GitHub. There are good reasons. And we're going to look at two different types of two different realization of this idea. The first one is I wanted my extension to run out of process. So I want all the new stuff I want to run on .NET 8 or modern .NET. In general, I'm really happy with that, but my extension needs to carry some additional component that can only be packaged in traditional extensions in a Visual Studio SDK extension. For example, my extension may need to package a project template or an item template, or what we're going to show here, my extension is using remote UI, but I need an advanced component, an advanced WPF component. So I need an assembly to be available to Visual Studio to load so that my extension from out of process can reference it in its XAML. So this is the first case, so fully out of process, but I need those advanced packaging functionalities from VSSDK. The other case is when you need both in-process components because you need to do things like interacting with some API that doesn't exist in Visual Studio SDK, or you have a dependency on .NET Framework, or you want to do advanced user interface using WPF, or there are some performance advantages that you are looking for by looking at being the same process as some other components in VS. So there may be a lot of reasons why you want something to run in VS. But you also want parts of your extension to run outside of VS, and that may be either for performance reasons, it may be for reliability, or because, for example, you have a dependency on a modern .NET assembly. So something that doesn't run on .NET Framework, but runs on .NET 8, or that's a scenario that's getting more and more common nowadays.
And in a lot of cases, it's something that you want to do and you want to take advantage of some of those more advanced features that may not be yet supported by the new extensibility model, or you're trying to factor in that certain components are supported by maybe .NET Framework versus .NET 8 or .NET 10 and all these other factors that come into play once you start getting a little bit more complex with the kinds of extensions you're writing.
Yeah, absolutely.
In other words, this is an advanced topic, people. Do not start in the middle of this playlist. So so I'm excited to see what this purely hybrid situation begins to look like for folks. So we want to hop in.
Yeah, absolutely. So we're going to look at this sample from our sample library that it's as usual on GitHub, so you can go and get all the source code, build it, file debug it, test it, and everything. So this is called an extension with traditional components. Honestly, I could not come up with a better name than that. Not very
It's
happy.
pretty straightforward. I like it.
But that's what it is. So it has two projects, an extension, which is fully fledged out of process Visual Studio Extensibility extension. This is just created with the template. So file a new project solution under extensions. It's down here somewhere, the Visual Studio.Extensibility extension. This one. Very easy. So create something and I called it extension. But now I want to package it together with some stuff that cannot be deployed through an process extension alone. In this case, in particular, I have a remote UI, XAML. And in this case, so this is going to use remote UI. Remote UI is the Visual Studio Extensibility UI system that allows you to build WPF UIs that run outside of the Venv inside the extension host. And it is all based on MVVM and completely based on data binding. So can do pretty cool stuff, but it has limitations. And the way you often work around this limitation is the really advanced UI stuff that you need to do with code behind. You would put it in a user control. And in this case, I just took another sample from this repo and I just packaged all the content of this window and I put it in a user control, which, by the way, it's this file here, but we'll see that later. So right now, what we have is we have an extension and we want to use this my user control that is going to be in a different assembly. And that assembly is going to be loaded inside of the vamp.exe. The extension project by itself is exactly what you expect. There's really nothing strange about it, except for this little line there where we say create v6 container false. We don't need, when we build the extension, to build v6 for it. So the package that deploys the extension, because we are actually going to use the tooling for building an in-process extension that has all the additional capabilities to package this
Ah,
content.
that's interesting. So in this case, it's the in-proc part of the extension that's gonna handle that. So therefore you can disable that
Yes,
creation in the in-proc and the out-of-proc. Can you do it the
yes.
other way around? Or is there a reason why you'd want to do it the other way around?
You could probably do it the other way around, but as we have seen in the last episode, the support for Visual Studio Extensibility in process extension gives you all the extra tools and flexibility and control, like writing your own V6 manifest from scratch and other things like creating a package def and so on. So you could probably manage to do it in both ways, but definitely this is the way that is the most natural. So you get the advanced part to include the least advanced part instead of the other way around. And the other thing that we're doing here, which is not strictly necessary in this case, but it is a good practice, is we are going to define an assembly with 6 subpaths. What it means is that all the content of this extension, the Out-of-proc extension, is going to be in a folder inside the overall container extension. So it's going to be in this Out-of-proc folder. The reason we do that is that we are going to have assemblies that are built as part of this extension that are .NET 8 assemblies and assemblies that are built from the container that are .NET Framework assemblies. And in this specific case, we don't have overlapping assembly dependencies, so assemblies with the same name from the two, so we are good. But if we did, we really don't want to go and mix a bunch of .NET 8 assemblies and a bunch of .NET Framework assemblies in the same folder with the
Right.
possibility that some of them will overwrite each other and then nothing will work. So we're going to keep it tidy and we're going to be happy when things don't break later.
Is there a good workaround for that in the event that scenario pops up where
Just use different folders. That's
Okay.
the workaround. That's a proper thing to do. Define the assembly v6 subpath for the auto process part. So all the .NET 8 stuff is going to be in a folder, and the root folder of the extension is going to be all .NET Framework. So now all the magic is in the container, and there is a little bit of it to see. So the container is an in-proc Visual Studio extensions, Visual Studio Extensibility extensions, same as we have seen in the last episode. So we're going to have the VSSDK compatible extension true and the .NET Framework set at net 472. We have a package reference to the Visual Studio SDK, so traditional APIs, and we have a package reference to the Visual Studio Extensibility build package, which is all the build tooling. This is different from the last sample we've seen. There's no reference to the Visual Studio Extensibility SDK package because we are actually not using any modern Visual Studio Extensibility APIs from this assembly. We're actually only using a few styles that come from Visual Studio SDK. We don't use any API. This is purely a WPF control that we are building. Something else that we're doing here, we have generated package.def files set to true. This is something that is generally set as false by default for Visual Studio Extensibility extension, but we set it to true here because we need a package.def file. The package.def file is a file with extension package.def that is inside the traditional Visual Studio SDK extensions, and it basically lists components that are inside the extension. In this case, the component we care about is going to let Visual Studio know that the container that we're building, so container.dll, is included, and Visual Studio should know about it and should be able to load it. And you do that by saying that you want to use code bases. So these two will make sure that the package.def is generated and Visual Studio knows through the package.def file that the extension contains container.dll. The other things that we're going to do is we're going to actually sign the disassembly. This is not code sign, this is strong naming, because if it was not strong named, it would not be loaded by VS. So we need to do this. And we need to have a signing key. So I just created one. There is no security component to this. This is a key that you can just have inside your repo. It can be public. It's only used to uniquely identify your assembly. So this is what we're doing, and this will generate us this DLL package in a V6. Make sure that the DLL is signed, that there's a package.def with a code base entry so that Visual Studio knows that it's supposed to be able to load that DLL. The other thing that we're going to do is to have this project reference. So this is where things get a little bit complicated. The container has a project reference on the extension project. This makes sure that the extension project is built whenever we build a container, since the container is going to have to include the extension inside of it. So we're going to go through this line by line because all of it is kind of interesting. So we are not referencing the output assembly. So all the code inside container does not reference the code inside of extension, any of the type inside of extension. The reason is even if it wanted, it couldn't. Extension is a .NET 8 assembly. Container is a .NET Framework assembly. So they're not meant to reference each other in any way. The skip get target framework properties help MS Build correctly build these two projects as a dependency of each other, while they have different incompatible target frameworks. If we didn't have this, container would complain and says, well, I cannot build this dependency extension because extension is used in .NET 8 and I don't know what to do with it. So this is, don't worry about it. We know better. Just go along with it. Including V6, it means that the content of the output of the extension build is going to be included inside the V6 of the container, and include the output group in V6, tell us which of the outputs of the extension build are going to be included. And we're going to pick this special output group that is called extension files output group. This is all the packages that all the files that would be packaged in extension v6 if we didn't turn on the creation of the v6 container. So everything that would be in the extension v6 is going to be output as the extension file output group, and it's going to be included here. There is only really one exception to it, and that exception is the extension.json file. The extension.json file is another manifest that describes all the content of the extension, so all the things that we have marked as contributions from a Visual Studio Extensibility extension are listed in extension.json. This file is not included in the extension files output group for reasons that we'll touch upon later, so we need to include it manually, and we'll say the v6 create a v6 source item, so an additional file that goes into the v6 and just grab the extension.json from where it's built and trust us, it's going to be there by then. And we're going to want it in its traditional place, which is inside the .vs extension folder. Except for that, everything is relatively straightforward when it comes to an in-proc extension. So we have an extension v6 manifest. Again, it is marked as an in-proc extension here, and all the metadata is going to be there. This means that all the metadata from the extension entry point for the out-of-process extension, so all of this stuff is actually going to be ignored because since we are not packaging the extension through the Visual Studio Extensibility traditional tooling for out-of-process extension, we are giving up on the v6 manifest generation. So what I did, I added the same information here that there are in the v6 manifest, but this one here are actually not used in any way. The ones that are actually relied upon are the ones in the v6 manifest. Again, in here, there's a user control. This is a normal WPF user control, so really nothing magic about it. At this point, this is just a normal assembly, not really a Visual Studio extension. It's just an assembly that contains a WPF control. If I go and build this container, it's just going to take a second, and we can actually look at what the v6 file looks like. So as you can see, first build extension.dll, which is a .NET 8 DLL, and then it builds container DLL, which is a .NET 4.7.2 DLL, and then the two and that packaged together into the container v6. If we look at this and we take the v6 and we open it as a zip file, we can see what's in there. So we have container DLL, we have the packaged file. So this is what we did with it. Contains a code base for container DLL in the root and the signing token, since again this is strong signed, we took care of that. So this is where the package def generation gets the result of package def generation. The source v6 manifest ends up being this extension v6 manifest. Everything that was supposed to be the extension project ends up packaged as we wanted inside this out-of-proc folder, except for the extension.json, which we handled manually and it's up in the .vs extension folder. And if we want to see what this thing does, this one creates this nice tool window. The tool window is completely defined in the out-of-process extension as a remote UI piece of XAML, and it uses the Visual Studio Extensibility, nice and simple to use tool windows APIs. But the actual piece of UI that I'm typing into it, so the name label, the text box, and the button, all of these are part of the custom user control that is packaged as the container DLL, and it is loaded inside the vam.txt. This is more or less everything for this sample, and I apologize for the headache that I'm sure I created and most of the people are listening to this.
No, I think it's definitely important stuff that needs to be heard because there are going to be those people out there probably watching right now who are like, "Yep, this is my use case that I need to figure out right now." So, yeah, it's cool that this option is even available. I think even with just like the template existing or the hybrid template option existing, I stumbled across it not too long ago, maybe a couple months ago when I was trying to write an extension on myself. And I was like, "Oh, that's nice." I didn't even know that that was even gonna be taken into consideration. So I think the fact that for people out there who are worried that the old model that they're either used to or contains APIs and things that are still very much needed for whatever reason, like, they're not gone. They made their way into coexisting with the new model if people need to do that, so
Yeah, absolutely. And we have project templates for the in-process extension and the out-of-process extensions. We don't have project templates for this hybrid extension. They have both because they are very much all one of a kind. So we're going to see right now another one that is actually relatively different. For this, we have samples, and you can go and see which parts do you need from each one, and you can come up with your own architecture. And each one of these samples have a README, and the README goes into a lot of details about why things are done, in addition to what are all those things, like all these changes and settings that I went through today.
totally, and all of those links to the related samples and things are also going to be linked in the description alongside the playlist link, so, uh, you shouldn't get lost.
Cool. So next, we are looking at this other sample, again on GitHub, which is called the composite extension. And this is the case where you want to have some stuff in the out-of-process part of your extension and some stuff in your in-process part of your extension. And you want to leverage Visual Studio Extensibility modern APIs in both of them, but most likely in the in-process part, you also want to mix and match some Visual Studio SDK APIs. Since you have two different parts of your extension, you're going to need them to communicate in some way. So this is going to be what we're doing in this sample. So we have a composite extension, which is the equivalent of the container. And the composite extension will package the out-of-process component project which is the auto-process part of it, very similar to the extension that we did in the other case. So we can give it a build, and maybe the first thing we're going to do is we're going to look at what this thing looks like in the V6, and then from there we are going to see how did we achieve that result. So let's do the same thing. We go find the V6 and we open it. Okay, now this has a lot more stuff. We're going to have the composite extension. That's the DLL that contains the Visual Studio Extensibility features for the in-proc part. Same thing as before, this part is in the root together with its dependencies. The V6 manifest, very similar. It's going to be sourced from the extension V6 manifest of the out-of-process part. So that part works the same. We have an out-of-proc component, so we did the same thing. And the out-of-proc component contains the out-of-proc component DLL, which is our actual out-of-process extension, and all of its dependencies. And now we see why we wanted to keep them nice and tidy. Because we now have things like, for example, Microsoft Visual Studio Extensibility.dll in this folder, and also Microsoft Visual Studio Extensibility.dll in the root folder. They are named the same, but they're not the same file. This one is a .NET Framework version of it. The other one is .NET 8 version of it. So they can't be mixed. If we put all the files together, nothing would work. And the other thing that's going to be interesting is if we look inside the VS extension folder, there's the extension JSON. This one shows all the things that, all the different features that are being contributed by this extension. So, for example, we have two commands. One command is coming from the composite extension. The other one is coming from, so the in-proc part. The other command is coming from the out-of-proc component, so the out-proc part. Even if we look down here, we have an entry point that is out-of-proc and an entry point that is in-proc. So these are really two extensions that are squished together in the same package there. So this is going to be, I'd say, fun to achieve. Okay, let's have a look at how this thing is done. we have the Out-of-proc component. This is basically exactly the same thing as the extension project we have seen last time. So we're not creating a V6 container, and it is in its own folder. And that's it. We're using Extensibility SDK and Extensibility build. In addition to it, we're going to compile into this project this interface that comes from the composite extension, and it's going to be this in-proc service, and that's going to be used to allow the two to communicate. But we're going to look at that later. The outer part, the composite extension container, this one is again very similar. It is a VSSDK compatible extension, and it's going to be an at472 project. This one has a reference to the Visual Studio SDK so that we can use the traditional APIs, a reference to the Visual Studio Extensibility SDK so that you can use the new Visual Studio Extensibility APIs, and the extensibility build for tooling. Again, we're going to do the same thing. There's an interface that we're compiling. This is this one, Out-of-proc service. This is an interface defined by the Out-of-proc component. We're compiling it in this project too, so that we can use it for the two to communicate. We have the same project reference as we have seen in the last sample. So a project from the container reference to the out-of-process extension. Again, we're not referencing the assemblies. We are skipping the target framework properties because they are incompatible target frameworks. So again, this is us saying to MS Build that we know better. We want to include it in the V6, so include in V6 true. And again, we are including the output group, extension file output group. This is what actually grabs all the files that would be normally built as part of the out-of-process extension and jams them inside our V6. Last time, we included the extension.json file in the V6 so that our V6 contains the list of all the features that the out-of-process extensions contains. This time we're doing it in a slightly different way. We're using this dependent.json entry instead of the V6 source item because we can't just copy the extension.json file in our VS extensibility folder because in our .vs extension folder, because this outer in-proc extension also is contributing its own Visual Studio Extensibility components. So each one of these extensions are going to have their own extension to JSON with the components that they contribute. So what this thing is doing, the paid extension of JSON tells the Visual Studio Extensibility tooling to go and get that extension of JSON and merge its content inside this extension, the extension of JSON of the in-proc part. And the tooling does it for us. If you're wondering, the tooling is brought in by the Extensibility SDK. So it's going to be actually the Microsoft Extensibility JSON Generator SDK package. So that's what does the magic. So this merging functionality, we couldn't even use it in our other project because we did not even include the Extensibility SDK for the out-of-proc part because the out-of-proc part didn't use any Visual Studio Extensibility APIs. But in this case, we're in this more complex world where each one of the projects is using the new APIs, and each one of the projects is contributing its own component. So we need to merge the two.
So even if you are doing like an out-of-proc piece of your extension, you don't necessarily need to include the Visual Studio Extensibility SDK edition in the event you're not using those related APIs in that
Yes.
context?
So in our previous sample, the in-proc assembly that we built was really not a Visual Studio extension. So it didn't have an extension entry point. The extension entry point is one of these classes that extend extensions. So one of the Visual Studio Extensibility entry points. It didn't have an async package, which is the entry point for VSSDK extension. It was just an assembly that packaged WPF component. In this case, the out-of-proc part is an actual Visual Studio extension. And so it comes with all the additional tooling that are needed to build the Visual Studio extension. We can now look at what we can do once we have these two parts. Because we have these two parts, we can put some functionality as one, some functionality in the other. but they are loaded in different processes, so they cannot communicate with each other. And so the usefulness of all of this is very limited. So we wanted to fix that. What we're going to do is we're going to build a way for the in-process part of the extension to talk to the out-of-process part of the extension. So the way we do that is we create a brokered service, this out-of-proc service. This is an iBrokered service which implements this interface, iAutoproc service. This interface has one method that can be called, which is called do something async. This is a sample. These are very much proof of concept. They don't do anything useful. They are really meant for people to learn how to employ these techniques. This out of proc service is going to implement this do something async. And what it's going to do is just going to show a message through one of these our units prompt that says hello from in-proc. So this method is meant to be called from in process, but the actual message is going to be shown by this process, which is out-of-proc. So showing this message from out-of-proc. And this is basically it. The weird machinery is in the brokered service configuration. So the way you build a brokered service, it has to have a configuration, it has to have a service name. So you can look at that. It's going to be a unique name, it's going to be a version, and then it has to define a moniker and so on. These are more advanced topics, so there is a little bit less hand-holding in our APIs, but we have quite a few samples that you can follow. And our build tooling is going to do its best to give you errors if you don't specify all the different components.
Yeah, because this one is a brokered service, but are there, like, other kinds of communication kind of services that people can or could
Yes.
use?
So we're going to stick with brokered services. Brokered services are the more modern type of services. So this can be used, can create a brokered service out of process, call its methods from in process or from out of process as well. Or you can create a broker service in process and call its method from out of process. So they allow a lot of flexibility. There are other type of services like traditional VS services, and we're going to see that in the next episode, where we're going to see at. So this is all, I would say, state of the art new stuff. And in the next episode, we're going to see. Okay, let's say that you don't want or can't use the new stuff, which would be broker service, and you wanted to use some of the older type of services. How do we interact with those? So we're going to see some of that next time. This is what defines a broker service. It has a name, it has a version, then it has this thing that's called the service descriptor, which basically describes how the service is going to to exchange its messages over the wire. So in this case, we are going to use message pack, which is the most compact and best performing binary serialization format that we have. So that's going to be our default for all our service. We're always going to use message pack, but you could use the things like JSON and so on. So once you define a broker service, you need to do a couple of other things in your extension entry point. So again, from out of process, because this is the out of process service, you're going to go to the initialize service method in the extension entry point, and you're going to proffer it.
What does that mean?
This basically means you're going to make it available. So it's going to say, well, this auto process service is now registered and available and provided by this extension. So the way you make this service available is by proffering it in the initialize services method and by having the Visual Studio contribution attribute on the class. Then how do you use it? Well, in the in-proc extension, we have a command which is going to get the service broker from the extensibility object. So the extensibility object is where you get all the Visual Studio Extensibility APIs. So that's what you use for modal dialogues, prompts, and so on. In this case, we're getting the service broker out of it, and we are getting a proxy of the out of service interface. This interface is going to be this file, Out-of-proc service, which is, again, we've seen it before. It is this same file. It's compiled in both processes. So this is actually going to be a different type because it's built into a different assembly, but it doesn't matter as long as it has the same shape. So it doesn't need to be the same type. It just needs to be the same, have the same methods on it. And out of it, we are getting a service, and now we can call do something async on the service, and we need to remember we need to dispose our proxies when we're done using with them. If we want to see what this thing does, it's going to be communicator from in process to out of process, and we get the message that we've seen before. So the in process command sent a message to the out of process broker service and show this message. The good thing is that the other side of this is very, very similar. If we want to communicate from the out-of-process extension to the in-process part of the extension, what we're going to do is the same. We're going to have an in-proc service. This is also a broker service that which implements an interface, this in-proc service interface, which again, it's built into both projects. Very similar, we have a Visual Studio contribution. There are slight differences in what this service looks like. Like in this case, we don't have the iBroker service interface. There are two Visual Studio contributions attributes here and here. The reasons for this difference is that this is a .NET framework project. So we cannot use some of the niceties like static members in interfaces that we can use in the .NET 8 flavor. So the APIs look slightly different, but it is the same thing that we're doing. And again, the README has a lot of details and shows all of these details. Same thing. We have a broker service configuration. The broker service has a name, a version, and the service descriptor. This also uses message pack, so no surprises there. Service audience, this is just what you have to do to make it work. It has to be local and public. And that's it. The interface looks surprisingly similar. It does do something async method, and that do something async method shows a prompt that says exactly the opposite of what the other one does. Said hello from out-of-proc because this is meant to be called from out-of-proc. But this message is being shown from in-proc because this is the in-proc broker service. So again, very, very, very similar. Same thing as the other one. We need to go in the entry point, and this one needs to be proffered. Here we go. The API call is slightly different. It has two parameters because again, this is the this is the .NET framework version of the API, which is slightly more complicated. Same concept. The service needs to be contributed and proffered. The way it's used, same thing. We have a command in the out-of-process part. This command is taking the service broker, getting an interface, a proxy of the in-proc service. When you get a proxy, you specify the interface that it has and the service descriptor of the service. So the service descriptor is the name and the version. You get a proxy, you can call the method, and then again, don't forget to dispose of your proxies. And if you want to see what that does, it's going to be communicate from out-of-proc to in-proc, and no surprise there, we get our message. That is all, I believe.
I thought that was pretty thorough, which I think is needed for the complexity required here. Yeah, and I'm assuming, again, we talked a little bit about debugging last time, about how it's totally cool in the context of in-proc. So I assume here when you're using both in-proc and out-of-proc pieces, I think you alluded to it, you can set breakpoints in either, and yes, it's gonna
Yes.
respond
If you
accordingly.
F5 debug this extension, you're going to have your debugger attached to both the vamp.exe and the extension host, since there are components in both. And you can put breakpoints in both places, and they will hit separately. Just have to remember then, just because one process is stopped on a breakpoint, the other one's not necessarily stopped.
I
But
imagine it gets complicated in, like, what similar to, like, when you're debugging threads or something, just trying to
yeah,
know which one are
this is
you on, what's the order.
yeah, exactly. This is two processes, so it's, let's say, the next level. The other one, the extension with traditional components, even if it's packaged as this type of hybrid extension, so when you F5 debug it, the debugger will only attach to the extension host because that's the only part of the extension that is contributing components. So if you wanted to put breakpoints inside the code for your WPF control and the code behind, you are going to have to manually debug, attach the process, and attach the debug.exe.
I like it. And again, yeah, I like the streamlining. Yeah, it sounds like the next discussion to follow from here is just more about how these components communicate with each other. Since we just talked mostly about brokered services, which is the most modern addition here. So
Exactly.
part
So right
yeah.
now we are in the context of a purely Visual Studio Extensibility extension where both in in the parts inside of VS and the parts inside of the extension host, they are both using all the new APIs and possibly sprinkling in some usage of, I don't know, DTE or some other VSSDK APIs. But there are no big independent components built with VSSDK. Next time, we're going to see what happens if I want to have, for example, an async package inside the in-proc part, or what happens if I have math components. All these things work, but we need to be careful about how we use them because they're going to all be independently instantiated as they're needed and they're all delay loaded. So the next one is going to be mostly about, okay, this is how I'm careful and I make sure that I build something that is reliable when I go with these very advanced topics.
Yeah, people can look forward to even more, especially in the communication realm. So that is, I hesitate to call it part 3 because I don't want to confuse people if you're following the playlist. Let's call it, if you see something involving in and out of proc in the title, or you're just clicking the next episode after this, that is your part 3 of this multi-part conversation we've been having about what to do when you need to create an in proc versus an out of proc or both experience. So cool. Matteo, anything else before we close out?
No, I think this is a lot already. I
Great.
rather not add any more information.
Awesome. So then join us for the next episode where we're going to be continuing our conversation more about how these two can communicate with each other going forward. And until then, as I mentioned earlier, the link to the full playlist is below. Also, we're going to be posting the links to the samples that are being used below, which contain their own readmes that go very in depth into all of this. So if you need a refresher, if you need to follow along, that option is there. So all of it will be included in the description. And join us for the next episode where we're going to talk even more. So until then, thanks for watching and happy coding.